area and perimeter. Have we ever heard about it from our primary and maybe senior 1 and senior 2? I hope some of you have covered some part of it. So who can tell us what they understand by the word perimeter?
The distance all around figure or a place.
Around a figure or a place. Okay, thank you very much. Any other? Okay. So in simple terms, we can say a perimeter is area around. So when we go around a figure or any place, then that gives us the perimeter. How about area? Anyone with an idea? Okay, to us who are not talking and sharing something, I would request that we mute our microphones and then we unmute them when we are going to say something. Thank you. So we have begun by saying that the area is the perimeter is around when we go around a figure or an area. So here we have someone, he's doing some, I think, mowing in the compound, and we need to find out how much he can go around or how much he needs to correct. So I'm saying we are calling him gardener, needs to work out the perimeter and the area of the lawn. So we need to know what he has to put in mind in order to come up with the perimeter and the area. So as somebody had just said, the perimeter of a shape is the total length of its sides. So when we go around the sides, maybe if it is a farm, if you go around the sides of the farm, then that will give you the perimeter. So we go around the figure. So we are beginning with the rectangle. So who can tell us the properties of a rectangle? Properties of the rectangle. Yes.
The length of the length is always longer than the width.
The length is longer than the width. Thank you. Another one?
Me.
Yes.
Okay. 4 sides.
It has 4 sides. Thank you. Another one?
The corners are always 90 degrees.
The interior angles are 90 degrees. Thank you. Any other that we have left out? Any other that we have left out? Okay. So when we go to the perimeter, so we shall begin with the one length. Okay. So when we begin adding from this side here, so it is length goes up to there. Then we have a width there. Then we again have the length, which is equal to the upper one. So these two are equal because those two sides are equal. So it is the opposite sides of the rectangle are equal. Then we again add the what? The width. So when we move around this figure, so it gives us the perimeter. So in simple terms, we can say it is equal to length plus width plus length plus another width. Is that okay? So we go back to our loan, the one who was mowing. So we find out the perimeter he had to go through. So that was 5, and the width is 3. So you can do where you are a simple calculation, and then you tell me the answer of what the perimeter will be in like 1 minute. So let each one of us calculate, and then we get the answer. Please, somebody who is giving us that noise, please. We can mute our microphones and only speak the answers. When you finish, you come up and speak. 15 meters, that is one answer. Another one?
16 meters.
16? 15?
16 meters.
16 meters, thank you. Another answer? Yes? 16. So it seems most of us are getting 16. And this is how it comes about. So who can tell us what he has done? Bridget, can you tell us the steps you have taken?
We shall add the length plus width plus length plus width.
Okay. So
We're
that
going
would
to
be
add the length and width multiplied by 2.
Thank you. So another formula she's giving us that we can get 2. We can get 2 into length plus width. Okay, so this will be 2 into 5 plus 3, and the inside one would be 8. So multiply that by, and it gives us 16 meters. Okay, thank you. So we can continue. Then we go to the area. So I'm saying area measures surface of something. So here we have, which figure is that?
A square.
A square. Okay. So we are taking a square of 1 meter and 1 meter as well. So we all know that all the sides of a square are equal. So how would we get its area? How do we get the area of this square, which is 1 meter? Whose sides are 1 meter? How do we get its area? No answer. Okay, let us first see different things. So this is 1 meter, 1 meter. So in the overall, we shall have 1 square meter. So when we get this side and this other side and we multiply them, so it is one side 1 meter, another side is also 1 meter. So we can say the overall is 1 square meter. Then we have another smaller one whose sides are 1 centimeter each. So that would also be 1 centimeter and 1 centimeter, and that would generate for us 1 centimeter squared. Then we continue to another smaller one whose sides are 1 millimeter. So it would also be 1 millimeter squared. So from there, we go back to our farm, to our Ron who was doing the mowing. So he had 5 meters long and 3 meters wide. So the best way here is if these are 5 meters, so we divide the length into 5 parts. So and each of them would have 1 meter. When we get 5 divided by 5. So like that. Okay, so that would have it split into 1 meter each, and that would appear here 5 times. So this is the first, second, third, fourth, and fifth. Then for the width, since it is 3 meters, we are also going to divide it into 3 equal parts. So that is 1, second one, and third. So here, who can tell us the simple way of getting the area from this? What would be a simpler way? No idea? At least you have something to say. We give answers, we give our opinions. So all answers are correct, but we shall choose the most correct one. So don't feel shy to speak out your answer. Arnold, what is your answer? Yes? Speak up. What would be your answer?
15.
15. And how would we arrive at the 15?
Multiply length times width.
Multiply 5 and 3. Okay, but before we go to that, which answer is also correct, so we could begin by counting these small boxes we have created inside. Okay, because at first the upper one was 5, and we said we divided that into 5 parts. So this was 5 meters, so we divided to have these small boxes of each 1 meter. Then here we divided 3 into 3, which are still giving us 1 meter, 1 meter. So if we counted these inside boxes, they would give us the area as well. So that is the first one, the second one, 3, 4, 5. Then we'd add another 5 to give us 10, and add another 5 to give us 15. So the area would be 15. And then that would bring us to 15 square meters, because we are getting this meter times the what? The meter, because each one of them is 1 meter here, 1 meter here, and that gives us 1 square. 1 square. So if this is 1 meter, and this one is also 1 meter, so we saw that this one would be 1 meter squared. So when we add all these ones, so we'll be able to get 15 meters squared. And then that would take us to the formula that one of us suggested, that area is equal to length times width. So this one would also be the same as getting 5, and we multiply it by 3. And that would still give us a 15 meter squared, or square meter. Any question before we proceed? Any questions? We continue. So we are saying the area is the length times width of the rectangle. Okay. Now we have our field here, which is 65 meters and 32 meters. And here we cannot now do it using the other first method of splitting into 65, because that would be a longer procedure. So we would be able to do that when we had a 5 and a 3. But here splitting them into 65 and here 32 would take us long. So we'd use now the area, the formula, which is length times width. So can each one of us get the answer for the area of this figure?
meters squared.
2080 meters squared. That is one answer. Another one? Others, are we working or not working? Michael, what is your answer?
I'm still looking
You are still working. Okay. Treasure, what is your answer? So I think those who are still working, we can a little bit stop and we go through it here. So you're saying that is 65 and that is 32, and you're saying area of a rectangle is equal to length times width. So you're saying area of the field is 65 times 65, and that would give us 2080 meters. But remember, it is a meter times meter, so it will give us meter squared. Then we have another rectangle there of a page, maybe a page of a piece of paper, and it has 30 and 21. So we can still do that using the same formula, and we generate our answer. I hope we are trying to find the answer to the area of this page. Treasure, have you got the answer?
Yes.
What is it?
638 meters squared.
Yes? 613.
630 centimeters squared.
Okay, thank you. Michael, is it the same?
Yes.
Arnold, is it the same? Okay. So I'm saying area of the page is 30 times 21, which gives us 630 centimeters squared. Then we have this figure here. So what do we do about it? They are saying it is arrow-shaped. So we are going to begin by finding the area, by finding the perimeter of the arrow-shaped room. So what do we do? Maybe let me begin by giving it so if this is A, I call this one B, I call this one C, this one becomes D, E, and then F. Bridget, can you mute that microphone and then you just put it on when you're going to speak? Is it okay? Okay, so how do we deal with this figure? So we are given AB is 5.2, BC is 3, we are not given DC, we are not given DE, EF is 3, and AF is 4.5. So how do we find DC? And how do we find DE? So who can tell us how we can find any of those two? So how do we find the DC? As all of us are keeping quiet. Michael, how do you find the DC?
To find DC, we'll go and
Yes.
take the length of AB and then
Yes.
subtract FE from it.
You subtract
FE from it.
Okay, so if we draw a line from here to join here, so this would also be 3 meters. So we get 5.2 minus 3, and this would give us, I think would give us 2.2. Okay, and this is equal to DC. Then anode, how do we find DE? What is DE equal to? I hope anode is still on listening. Bridget, how do we find DE? Bridget and your friend, how do we find DE? Treasure, how do we find DE?
get the length of DE, we'll
Yes.
we'll get the length of AF minus the length of BC.
Minus the length of BC. Thank you. So this would be 4.5 minus 3, and that gives us a 1.5. So here is 2.2, and here is 1.5. Now, how do we find the perimeter? So remember, we said perimeter is the distance around the figure. So how do we find the perimeter of this arrow-shaped room? Michael?
Yes, please.
How do you find the perimeter of this figure?
We just check the length of all the lines and add it up together.
And add it up together. Okay. So that we said is 1.5, that is 2.2, which answers are correct. So perimeter is 3 plus 1.5 plus 2.5 plus 3 plus 5.2 plus 4.5, and that gives us 19. So we began from BC. So we added this 3, we added the 1.5, then we added the 2.2, and then 5, and then 4.5, and finally another 3 somewhere here, which should be this. So the final answer is giving us 19.4 meters. Then now we go to the area of the shape. So who can give us suggestions on how we find the area of this shape? Because we are not now going to do the length times width immediately, because it is arrow shaped, so it is not a direct rectangle that we are going to multiply length times width. So how do we find its area? So I think everyone should give a suggestion. Let me begin with Treasure. We? What do we do?
We divide the 5.2 centimeters by the 3 meters to create a square of 2.2 meters and 3 meters, and create a rectangle of 4.5 meters and 3 meters.
4.5 and 3 meters. So we do like this. We create this.
Yes.
Is that what you are saying?
Yes.
Okay.
Yes.
Any other suggestion? Yes, Arnold. How do you find the area, or what do we do to find the area of this arrow-shaped room? Just speak louder. We are not hearing very well.
You are going to get the
length and the width.
Yes.
Then we shall say area equals to 4.5 centimeters plus times 3 meters.
So that would be area of this.
Times 5.2 meters times 2.2 meters. Yeah.
Thank you.
That's my answer.
Yes.
Welcome, sir.
Then Bridget and your friend, what are your suggestions? Bridget? Okay, let us see what is done here. So one would say we separate like that. So another one would separate like this, taking the 5.2 and the 3. And another one would create and make it a complete here, so that this becomes 5.2 and 4.5, and then gets an area of this small figure here, and then we subtract. But let us see those different options. So if the separation is done that way, let me first rub off some of this. So if the separation is done like that, and we have our A and B, so I would say area of A is 4.5 times 3, and that would give us 13.5 meters squared. So that would be area of A. And then we get area of B, which will be 3, which is can act as our length, then times 2.2, and that would give us 6.6 meters squared. Then after that, we would get area of A plus area of B, and that would give us a total of 20.1 meters squared. So that would be one of the options. Then another option would be when we split and have a length of 5.2 here against 3, and then we also have another one here of 1.5 against 3. So those two. So let us see. Area of A would now be 3 times 1.5, and that would give us 4.5. Then we get area of B, which is 5.2 times 3, and that gives us 16. And then after this, we'd still get area of A. Total area is 4.5 plus 15.6, and that would give us the same answer of 20.1 meters squared. Then another way would be when we complete this and first make it a complete rectangle. So this means this we add here is 2.2. So area of the large rectangle would be 5.2 times the width, which is 4.5, and that would generate for us an area of 23.4 meters. squared. Then we subtract area of a smaller rectangle that we have created, and that would be 2.2, which is here, times 1.5, and that would give us 3.3 meters squared. But since we created this rectangle here, and it is not part of our original arrow-shaped room, so we are going to get area of the bigger rectangle, and then we subtract area of the smaller rectangle. And that will be total area would be 23.4 minus 3.3, and still that would give us 20.1 meters squared. So that is, unless if we have some questions to ask before I ask you my questions. Yes, Martin, how are you? You have just joined. So his mic is still off, but he has just joined us.
Hello?
Yes. You have a question?
Yes.
Okay. You can ask.
How have you find the area of B?
Area of B.
Yeah.
Okay. Area of B. Let me first go back. This B here.
Yes.
So this B is from here. So it goes like this. So maybe if I could pick it, let me first remove these ones. So if I could only pick the B, so it would be like this. So this is 5.2 meters, and this is 3 meters, and this is our B. So the area here is 5.2 multiplied by 3. Are you now getting it? Length times width. So our length is 5.2, and then our width is a 3. Yes. Have you now got it?
Yes.
Okay. Any other with a question? You're welcome. So in these few remaining minutes, let me request each one of you to tell us what you have learned today.
Mister,
Yes.
perimeter of a rectangle.
The
Perimeter of a rectangle.
perimeter, we add up the sides.
Okay.
We get length plus width plus length plus width.
Okay.
Or we get 2 bracket length times width. Let me write it here. Two into length plus width, because the length is appearing 2 times and the width is also appearing 2 times. So that is how we do it.
Yes.
But again, this lesson has been recorded and it is going to be again shared in the group, so you can still watch it and then understand more.
Okay.
So I guess our time is up. Let me give you some work to do, so you can get a book and write it. Then we shall go through it later when we come back for another lesson. So that is our activity. So what does the word perimeter mean? You write it, then when we come back we shall ask for those answers. How do you find the perimeter of the shape? What units are used for perimeter? Then how do we find the area of a shape? And the units used for areas? And how do we find areas of this shape? So we have a shape there, so how do we find its area? So we have the first shape, it's there. Then we have the second shape, which is also there. And another one is also there. So after you again play this recording that they will share, and then you do that work. So another one is there. And that brings us to the end of this lesson. And we hope to meet again.